Greetings to all. In this video, let's see about the topic DIO binary signaling. DIO binary signaling is an example of correlative coding. Let's go to the topic. So first, what is the major use of this DIO binary signaling? So DIO binary signaling is mainly used because in DIO binary coding we can transmit the data with the reduced bandwidth. Okay. So that's what the first line says. DIO binary modulation is a method of transmitting R bits per second with less than R by 2 hertz of bandwidth. So we all know in communication theory, based on the Nyquist sampling theorem, okay, if you want to transmit R bits per second, and if you want to transmit the symbol without inter-symbol interference, ISI, okay, the minimum bandwidth should be at least R by 2 hertz. But in case of DIO binary coding, we are transmitting the data with less than R by 2 hertz of bandwidth, which may introduce ISI. But however, it may introduce ISI. Okay. So this ISI is introduced in a control manner so that we will be able to subtract out and recover the original, the input signal without any loss in information. Okay. So let's see the block diagram, the encoder block diagram. Here, what you see is a level converter or input level sequence. Okay. What the input that we get here is zeros and ones. Once the input comes to the level converter or the input to level sequence, we may get either a plus 1, we may get a value of plus 1 or minus 1. Okay, so AK is going to be a value with plus 1 or minus 1. So you see here, okay, so AK is going to have the value of plus 1 if the input bit is 1, and AK is going to have a value of minus 1 if the input is 0. Okay, so this input is added here. You can see here the same input is again passed through a delay of dB. Again, it is getting added here. Okay, then it's passed through an ideal channel, and the output is collected in a sequence where we call it CK. So output CK is nothing but the summation of the input signal AK and the delayed input. Okay, so output you can say is summation of AK plus AK minus TB. Okay, because we have a delay of TB, so we can say AK minus TB. Okay, that's what we could see here. Okay, CK, the output is nothing but the combination of AK plus AK minus 1, because if you're going to delay by a factor of 1, so we can just say output is going to be summation of AK plus AK minus 1. We are having a delay of TB, so that's going to be the output. Okay, so basically in DIO binary encoding, so the input will accept two levels will be of 2 levels, whereas in the output we may get 3 levels, 0, plus 2 and minus 2. Okay, so the encoder accepts 2 level sequence. Okay, the case input, and this input is converted into an output in the encoder which has 3 levels, which will be plus 2, 0 or minus 2. Okay, we'll see with an example. Then we have a decoder. If you want to reconstruct back this original signal, this is here you can see a block diagram where to reconstruct the original signal you can say AK cap is given by CK plus minus of AK minus 1. Okay, we'll just go into the delayed input AK minus 1, and it's going to be a combination of CK and AK minus 1, where AK cap is going to be CK minus AK minus 1 cap. Okay, this is the formula if you want to reconsider the original signal. Okay, let's see the DIO binary coding with the example. Be easy for you to understand. So as I told, this is a transmitter. Okay, imagine we have the input sequence. Okay, BFK, it is which consists 0 and 0 1 0 0 1 0 1 1 0 is the input, and here we have the after passing through the level converter, we may get an amplitude of +1 or -1. So 0 will, when you pass through 0, you get a -1. Again, when you pass input of 1, you get amplitude of +1. Okay, for 0 it is -1. Okay, so what we said as per the theory is, so output Ck is nothing but, okay, here the notation is slightly changed, where you sign the formula Ak plus, okay, Ak minus 1, right? Here the notation is, okay, I used Bk, so it's actually Ak plus Ak minus 1. Okay, so let's imagine that, okay, the first the input is input is 0, and we are having the value of -1. Okay, so let's start from the second bit. So Ak is always going to be this value, and Ak minus 1, okay, is going to be the previous value. So the output is going to be the combination of the Bk. Okay, here it is Bk plus Bk minus 1. Okay, here you are taking notation as Bk, don't confuse yourself. So it is -1 plus -1 will be -2, and here it will be like 1 plus -1 will be 0, and -1 and +1 will be 0, and 1 minus 1 will be 0, and 1 plus 1 will be 2, and -1 and 1 it will be 0. So what you could see here is, as we told, initially we had only 2 levels, okay, -1 and 1, but whereas here you could see 3 different levels. Like you can see a level of -2, you can see a level of 0, and we can see a level of 2. Okay, so the 2 level is actually converted into 3 levels here, right? So then let's see the receiver or the receiver side, and you all know the formula for receiver side, right? You know, Ak cap, okay, is nothing but Ck minus Ak minus 1. Okay, let's come back here. So what I'll do, I'll just repeat the same output here. Okay, Ck, the receipt sequence Ck is -2, 0, 0, 0, 2, so I'm just repeating, okay, Ck. So we all know the output, okay, Ak cap is nothing but Ck minus Ak minus 1 cap. Okay, so what is Ak minus 1 cap? And it's nothing but, you know, the previous value. So from this table, this is Ck, and if it is Ak minus 1, it is going to be this value. Okay, let's see here, Ck minus Ak minus 1. So it's like Ck minus Ak minus 1. So we'll start here like -2 minus of -1. Okay, it will be -2 plus 1. You will get an output of -1. Again 2, 0, you have CS 0. 0 minus of -1. Okay, 0 plus 1 will get output of 1. Again 0 minus 1 will get output of -1. Again 0 minus 1 will get output of 0 minus of -1 will get output of +1. 2 minus 1 will get output of 1, and 0 minus 1 will get output of -1. So then, okay, with the help of decision device, what we can do is, if any value is greater than 0, greater than 0, it we consider as 1, and any value, okay, it is lesser than 0, we can consider to be -1. So for the -1 will be converted. So based upon decision device, we can say that the -1 is converted into will have an output of 0, and +1 will have an output of 1. So this is all about our dual binary signaling. So the major drawback of this dual binary signaling is that, here's a drawback. If we receive one error, okay, this error is getting propagated. That is a major drawback. If Ck is received with error, okay, then Ak will have an error, and error will propagate at output. So if one bit is going to have error, that error is going to get propagated in the other bits also. Okay, this is a major drawback in this dual binary coding. Okay, so it's dual binary signaling. So in the next we will see how to overcome with this drawback. Okay, the next video, the next talk, I'll discuss about how we are going to overcome this error propagation, this error propagation, the decoder, okay, with the help of a pre-coding technique. Okay, so thank you.